Welcome back. I'm going to be doing a lot of my work through a graphics render engine, so fundamentally we're going to be working with our data inside of images, and this is just a pictorial way of representing our data, from converting them from matrices to color values and transparencies and all that kind of thing. So it stands to reason that the dimensions of the image will be directly correlated to the dimensions of the matrices that we're working with. So before we do anything too complicated with data, easiest way to start sort of translating from the JavaScript code that I'm using for prototyping and Python, which I'll be using for all my image processing. I'll do a demonstration of both, how to do image manipulation in both JavaScript and Python, so that we can kind of switch back and forth going forward without having to do so many of these long-winded tutorials. And basically the object for today is just going to be to get some random data and turn that into an image, basically, so that we can see what in Blender would call a texture map or an image map might look like with random digits sort of filling everything out. So it'll basically be a noise filter. That's basically what we're building. So to start things off, I've got this empty folder here, and I'm just going to start with the JavaScript side, and then after I get the JavaScript going, I'll do an install of a library called Pillow, and I'll be running image processing through that library with the Python side. But in JavaScript, we can do it all right in the browser, because they've got the canvas elements got some built-in methods that we can use. So I'll just call this one image manipulation. I'll call it live just because I had to practice ahead of time, just so that make sure it wouldn't take forever. Make sure I could actually do it, because I haven't done any of this before. So not specifically this, I mean, JavaScript's not really meant for this, but like I said, I'm just using it because it's a quick and easy, dirty way of prototyping things. Since the browser's got everything built in, there's not really any need for learning new libraries or, overcomplicating things. So I'm just going to use this standard HTML setup like I always did before, and I'm going to close off my script tag. I guess I need an image first, so I'll save this. I'm going to open up GIMP, the image editing program that we were talking about before. Showed a demonstration on it before, And I'm going to create a new image, and we're going to keep it really small because our data is not going to be nearly as huge as most images are, because that would just make processing take forever. And I guess I don't really need a crazy resolution here because it's just for demonstration purposes. RGB is fine. Good stuff. 2. There we go. Okay, so just to make sure things are working, I'm going to try to pull up the bit stream so that we can see what the actual bytes of data look like with our color information in it. So I want to make sure that this top corner is just got some information in it, otherwise I'm just going to be seeing a ton of zeros. So I'll put a little bit of red, and sure, call it a little turquoise. Now you see the image is really pixelated, but that's because I chose a really low resolution, and most of the data we're going to be working with is going to be like no more than 128 bytes. I put 64 in this case, so in case you're wondering why it looks cheesy, it's just because that's going to be much quicker to render and process. So I'll just make a little smiley face here, and then I'll black out this corner too, just again for when I'm looking at the raw data, so it's easier to see that there's actually something happening. It's not just all blank, all blank or all filled out. And I'm just going to export this as a regular PNG, and I'll call it smile. Export, sure, cool. Okay, so you'll see I've got that image here, and if I open the folder, the image is just a really pixelated smiley face, some junk on it. And I don't need the side window anymore, so I'm just going to close that up with Control B. And I want to make sure that everything's running on my live server. Control Shift I to open up the console here. That's where I'm going to be outputting our data, just so we can see it. And Alt space and then always on top, so Alt space T if you're on Linux. Refresh. That way I can type and the window stays on top over here. Good, so it looks like we're all set up, and if I change this, okay, so I'm going to create a bitmap of the image element. Well, it's not really an element though, so of the image I created in GIMP. And the way I gotta do this is I gotta make sure that the image is loaded before I start doing any, or trying to get any image processing or anything done. So I'm gonna have to use asynchronous code to do this, and if you're having any issues with this and you're not running the same type of setup I am, you have to run this JavaScript on live server so that you can run asynchronous functions, because you might have issues depending on the browser you're using or the IDE environment that you're running on. So it's just easier to use VS Code with the extension live server. What is it? Live server? Yeah, that's the one I'm using. So if you use this live server here, it actually runs JavaScript server side, so you won't have any issues. So to start, I'm going to just call the image something here, and that's going to have to be the result of my async function. So use the async keyword and write a function. And inside of that function, first I'm going to have to fetch the image and then wait for it. And then once I get the image, I'm going to have to get a what's called a blob, which is just the binary bit data from the image. And then from that, I'm going to create an image from the blob. And then I'm going to draw the image. And then I'm going to get the image data from what I've drawn. So draw image is just a way of taking the image data and actually kind of injecting it into the canvas element, so that when the canvas element's context, which is that little drawing window or whatever that's that we use to manipulate things inside of Canvas. So first things first, I'm going to get the image data. So I'll just call it temp, because I don't really need this after I fetched it. I just need it temporarily so that I can have a little placeholder to store the image I'm picking up. So dot means current directory. So it's going to look in the same location as this file. It's going to look for the smile.png that I created. And then after it's awaited for that, I'm going to get a blob, and that blob is going to have to await the temp, and then I'm going to call the blob method. So this will be built in with this. When fetch fetches the image and stores it in temp, temp is going to have a built-in method called blob, which just returns the binary data without like converting the PNGs, the image file, into an actual image to display. It's just going to give the raw bit data, which is what I want because I'm going to create an image out of the raw bit data. So with bit, I can then await, and I'm going to use this create image bitmap is a built-in from the browser. This is one of those things why it's easier to run a JavaScript prototype than, for instance, Python or something, because with Python, this method is going to be different depending on the different libraries you use, and then it's going to return different things and take in different arguments. So it's a little bit harder to talk about Python stuff without using specific libraries, whereas with a browser, everybody's going to be using the same libraries by default. So it's just it's a lot easier to manage just like thought experiments and prototype code through the browser when everything's standardized, basically. But there are benefits to having Python libraries because obviously they're going to process much faster. You're going to get the one that does specifically what you want, so there's a lot less overhead in computing. So it's not to say that this is better, it's just that it's better for demonstration purposes because it's more universal. And there's no installations and things like that you got to worry about too. So within my image context then, I'm going to draw the image. And it's not literally going to draw it, it's just basically going to take bit data and convert it into an image. So I have to give it the bit data that I gave it, and I'm going to position it at 0, 0. And then I need... once it's been created, then I have to get the image data, which is going to be the image data from the context of the canvas element that's rendered in the browser. So I'll just call that bitstream, I guess. And ctx.getImageData. And that's going to be from position 0, 0 that I gave it. Well, since I'm creating the image here, I can actually just use the width and height from that object. Yeah. Believe that should work. Oh, why not test it? Console.log bitstream. Oh, got myself an error. Tag names is .define. Document.get element by tag name. Okay, so our screen went dark. That's good. Image. Uncaught in promise. Create image map on window. One argument is required, but 0 are present. Create image bit. Oh, I have to put the blob in there. Obviously. Because I'm taking this to create my image bitmap from. Remember, so temp is going to get the image itself, like the whole bundle, the file. Then blob is going to get the binary data from that bundled file. And then the bitstream is going to create or the bitmap, I should say, is going to create a image bitmap from the blob. Then I'm going to draw it into the context using that the bitmap. And then I'm going to get a bit stream, which is all the byte data for each pixel value in that image, using the context, the image that I've drawn inside of the context. I'm going to use that to extract my bit information and store it in this bitstream variable. So there we go. I've got my image being drawn into my context on the canvas. I remember the canvas is this whole gray element here because I've where is it? Right here. Changed the background color to it. And if I look in, this is that fetch request, it just returns a promise, so ignore that part, but this is what's really important. And let me just pull up my... I gotta open OBS there to make sure my face isn't covering everything. So here's the image data specific to this. sRGB means just there's no alpha channel, there's no don't mind the HVAC. There's no alpha channel, so it's just straight red, green, blue values. They're 8 bytes, so 255, 0 to 255. That means there's 256 numbers for red, 256 numbers for green, 256 number values for blue, and the higher the value, the more of that color is being applied to the pixel space, yada yada. But if you go into data here, image data, and remember this is from line 36 where I'm just console logging out the bit stream that I got from the context. So I'm putting the image into the canvas elements context, and then I'm storing all the image data from the canvas element context into this variable here. And what's important is when I look through here, you'll notice that there's this big long array, all this stuff. And you see all these 255s? That's all the white space in here. So when I started at the top left corner there and put some color in, this is my red, green, blue, and every third index of the array is going to be the color value for that pixel, which is really useful because that means that we can essentially put any numbers in here as long as we follow the right order, and it goes, top left to bottom right, and just goes across the screen 1 pixel at a time. And that's why this array is so huge, is because 64 by 64 is what, 1024? 4096. So I got a 64 by 64 pixel image. That's what we created in GIMP. So that's how many items in the array there should be. And then that number times 3, I should say. 4096 times 3, 12,288, because we're going to have 3 color values for every pixel. So looks like my math's a bit off. I'll figure that out later. But what's important is we got the image data running, which is huge because that's what took me the longest. I didn't realize right away that we had to use asynchronous functions for these callbacks here, so I was struggling with it for a while. But good that we got that sorted out. So now I'm going to give my window some time to figure out, to rip all this data out from my... Oops, let me just see how much room I got here. There we go. So I need to give the browser some time to render all this before I can grab the image data from it. And that means that I'm just gonna use a set timeout because that'll be easiest. So set timeout, and basically it's a delay that I'm putting in here, an artificial delay, just to make sure that there's enough time that's passed, and that's just the number in milliseconds to wait, that enough time has passed that this can be run before it tries to display anything for my image data. I'm just trying to think off the top of my head here how to match the number of array elements I should get should be the dimensions of my image times RGB, which is red, green, and blue values, because each array element on here is one value, or each pixel is 3 index values. But that's not matching my math. It's bugging me. But anyway, I'll figure it out after. Focus. I'm going to get my... let me call this image data, because I'm going to throw another... I'm going to generate an image after that. So this one will be... I'll call it retrieve image data. Yeah. Guess I should just call the function. Do things properly. Okay, so that returns a promise. I get undefined at 42. Why is that? This is my issue. I gotta call it here, and because it's returning a promise, I have to use a then method. So the way promises work is you get a resolve reject. I don't want to get too much into it because this isn't supposed to be a tutorial video. It's just outlining the process so that I don't have to explain it every time I do a video and jump back and forth between JavaScript and Python for when I'm prototyping. But anyway, this calls all of this. So everything that's in these parentheses here, open and close just calls it as a function, returns bitstream, and sticks bitstream into the then statement to fulfill the promise. And then when the promise is fulfilled, it's going to give me a resolve. And I'm going to need a global window variable, global variable. This is really bad practice. It's just to show proof of concept, basically. But you never really want to use global variables in the first place. But secondly, you don't really want to instantiate them this way. But demonstration purposes, this will be the quickest, simplest, dirtiest way to do it. So now I can just use image data and image data. Booyah. So now I'm getting what? 16,384. Let me try this again. So 64 by 64 times 3. What if I did, maybe there is an alpha channel. Oh yeah, that's right. Okay, so here's the thing. When I'm creating an image with the context, it's giving me that extra alpha channel even though I didn't ask for it. That's why it's I'm multiplying by 4 here instead of 3. So I only have the 3 values RGB, but every one of the pixels is seemingly going to be defaulting to an alpha channel of 1, because there is no transparency in this image. Yeah, that's probably why. Anyway, so 16,384 is the length of the array that I get back from my image data, and uint is just a 8-bit. So 1 byte is 8 bits. Cool, so that's working. And that means my length should now also be working. No? Retrieve image data. Just image data. There you go. So I guess I could, but I really don't need all this. Just the 1 will be good. Oh, I guess just for the sake of demonstration, if I just put 5 milliseconds, oh, well, doesn't need that much, I guess. 1 millisecond. There you go. See, I'm getting image data is not defined because 1 millisecond isn't enough time to run through all this code. That's why I'm putting that delay on there, but I'll just stick to 75 so it always works. And then image data gives me this color space, sRGB, 64 by 64, my array buffer. Yeah, so you can check all this out if you want to really get into the nitty-gritty nuts and bolts of everything. But what we came here for was building. I want to build and create an image out of nothing. And to do that, I'm going to use the same functions sort of that we used before in other videos, the random number generator. So just to get this running, and again, I'm going to be doing this in Python, and I just want to have something to compare, like image processing in JavaScript versus Python. Ugh, having issues. So I'm going to create an image that's just 100 by 100 with a bunch of random numbers filling in the color values. So it should just look like random color noise. So I'll say let dimensions equal ndim, and this is just a default value, so if I put in another number because I want to change the image size, I can just manually do that. So I'm going to make our colors just equal an empty array for now, and then I need a nested loop because I need to run every pixel this way and then every pixel this way. So that means for let I equal 0, where I is less than dimensions, yeah, then I plus plus. And then in that, I'm just going to duplicate this. And I'll switch these from I to J. So I'm running a loop inside of a loop. So for every one row, I'm going to do all my columns, basically. Or for every column, I'm going to do all my rows. Doesn't really matter which way you look at it. Essentially, I'm going to be doing the same thing anyway. So now I want to take my R colors, and I just want to throw a value on top, and they're going to get processed in order because the loops are going to be processed in order. So that's easy. I need, well, math.random gives you a floating point number. That's any number between 0 and 1, and I just want fixed values because all of these numbers in my color arrays are between 0 and 255. So I'm just going to math.random times 255, and then I'm going to wrap all this in a parseInt, which just parses whatever is inside of these parentheses. It parses it into an integer data type so that there's no floating point afterwards. And I want to do that for 3 colors, so I'll do that 3 times. And again, this isn't the most efficient way of doing it. This is just a quick and dirty prototyping. Don't consider this proper code. So I'm going to make an image out of this by saying context.createImageData, and I want to offset that a bit just so that it's not overlapping with this image I've already got here. So I'm going to have it kind of sitting further over here. So dimensions is just 100. It's going to be 100 pixels off of this 64 pixel image. So dimension, and I'll offset it by dimension. Oh, dimensions. Yeah, dimensions. And then for the colors, so this is just going to default to a blank image for now. So what I need to do is use all the color values I put in here and then have those replace the ones that are in this blank image thing here. So colors.forEach is just an array method, and I'm going to need the index, so value and index, because the index of this array here is going to match up to the index of the data in the object that's created by the context here. So that means image.data, and then I'm going to use the index of the color that I'm iterating through, and I'm going to set that equal to the value of the current color value at that index. So what that essentially should do is give me 1 color or 3 colors for every pixel, just like the image data comes from the built-in method here. And then I'm going to be assigning it to an image that I've created, which is just blank and empty, and I'm going to be replacing all the values in there. So to do that, I need to use put image data, but after this has all been populated. Yeah, so context dot put image data, and that's gonna take what, 2 arguments, I think. So it's gonna take for sure my image, and it's gonna take my offsets. Oh yeah, these will be my offsets. This is actually gonna be the dimensions of the image I created. Duh. I think I said that backwards before. Anyway, so I've got all this in my create random image, and that means I just need to return it. Yeah. Yeah, sure. I don't think I actually need to return it because I'm throwing the image data directly in the context here, but just in case I want to look at it later, it'll just get thrown out basically if I don't use it. But create random image, and I'll leave the default as 100 so I don't need to put in any arguments here, and I think that should, oh go! Oh yeah, it did work. Okay, good. A little hard to see because of that background because I tried to outsmart myself. Anyway, and as you can see, every time I refresh it, that offset is annoying. Divided by 2, divided by 2. See how it overlaps? That's what I was trying to avoid before, but anyway, you notice every time I do this, I'm changing the noise. Basically, it's a noise filter. So I've created a texture map of noise, but you could see how this would be useful, because if I had real data instead of just random numbers, this would actually show up as patterns for things that are correlated, but those correlations might not have been readily apparent or obvious without throwing them into a picture, because XYZ or RGB and XY coordinates, that's like a 5 dimensions, right? So if you've got a patch of red in one local space, it'd be really hard just from looking at numbers, from like 5 columns worth of numbers to see that, you know, 1 or 20 rows out of 16,000 rows have some type of correlation, right? So that's the benefit to throwing in a picture, is our eyes are pre-tuned to spot patterns. So instead of having to write scripts to spot the pattern and then tell us what they are, we could just generate an image from any random set of data and see if there's some types of clumping or clustering or patching or anything like that happening with the data we have. So yeah, that's cool. We've got a random number generator, or texture map generator. That a second to pop up. Okay, so I've got the folder open now. It's just empty right now. I gotta create a notebook for it, so let's do that. Rename it to image manipulation 5. And let's just check OBS to make sure you can still see. Groovy. Maybe I'll move this down. Whoop. Okay, so I need to put my image in here. It's this smile thing. Paste that image like I normally would in here, just so I have something to work with. So I'm gonna need some import modules. I'm gonna work with saving and manipulating these pictures with filters like I didn't do in the JavaScript version, because we basically made the filter but we didn't process any filters. So instead of just copying what I did in the JavaScript version, I'll add a little bit of what do you call it? Panache, some flair. So first things first, I need to import my module. So I need base 64 because I'm going to be converting, because I'm going to be using blobs and bitmaps and stuff like that. I'm going to need pillow, which is that library I talked about before. Image as image. So this is going to give me the image object from the pillow library. I need IO because I want to save the changed and edited and altered images that I'm using. And I'm going to need, I don't know if I'll need NumPy, but actually I'm just going to import it anyway, just in case. Okay, so run that, no problem. Save it. I guess I don't need that window anyway. So first things first, I'm going to open the image, and that means I need a width. So width open. That's just the file path. I don't know why I'm spacing out here. And I need that to be in bytes. So RB is going to get me to be able to read it as bytes, and I need to give it a name so that I can work with it. So that'll be image file, I guess. And then I'm going to make a string out of that image. So base 64 library, this is when that'll come in. And the method for that is b64 encode, I believe. And that's going to need the image file that I threw in here. And it's just going to need to read that. So if I just print str, we will see if that worked. Beautiful. That's my picture, 64 by 64. Notice the B there just says, hey, we got bytes coming in, and then everything between the apostrophe, the single quote, everything between that is our byte data. So the string is useful in the sense that we can throw it around and I can dump it somewhere else if I want, but it's not entirely useful as far as being legible. So this was the string value. And I'm just going to do a little bit of cleanup here. Just so I can kind of separate all of the chunks I write here in the stages. So I'm going to assign this a value. Image string, just in case I want to use it. I don't think I need it because I'm just going to import it again later. But well, screw it. Let's just play around with Python a bit. I haven't done much Python coding, so I'll make a list out of the image string just to play around. I don't really want to do tutorials on code specifically, mainly because it's not my forte, but I'm using it because it's useful, not because I'm pro at it. But this is the same thing as saying str, and I'm really not really going to do anything with this anyway, but list is an array, just like JavaScript arrays. So nothing too fancy or fantastic with that. It did seem to convert them into digits though, which is strange. But these are string values. That's not actually the image color values, so don't be confused. I'm going to take that out. That's just going to give headaches down the road, because I'll probably forget that. So, well, I've imported NumPy, so I might as well use that too, since we're already going. So, a NumPy image, I'll call it. I'm going to use image.open, and same thing as before, with just giving the file name. And if I wanted to make an array out of that, like a NumPy array that is, I'm going to use np as array, and then NumPy image, that's what I call it. So what I'm basically doing here is I'm just using image from pillow, opening up this file here and saving it to NumPy image. I'm going to make a NumPy array, which is np. I'm importing NumPy as np, using the asArray method, and then dumping the image into this method, which will break it into a NumPy array for me, which is one of the many wonderful things about NumPy is how it manages and builds and manipulates arrays. So if I say like pillow image from NumPy array, just because I'm going to forget what all these are if I keep redoing this over and over again in different ways. I could say from array image array, and then print out pillow. Oh, why did I make that so long? Copy and paste, baby. Let's just do that. Oh, that didn't help me. Oh, image array. That's the one I wanted. I did all that typing for nothing. So, as you can see, NumPy just threw it away, but these are actually my color values. These are what I wanted from all of this. The 255s are all the white space, and then whenever there's been color changes or whatever, that's my RGB. And then I presume these are all laid out X, Y. I guess it'll take it from the dimensions of the picture, so it'll know that every 64th index is going to be the next row. So that's probably, I'm just guessing how it's figuring that out, because it's not actually indexing the XY locations to denote which pixel this is, but I can tell that this is the first pixel because, well, I drew the pixel deliberately for that reason. That's this top corner here. R is red, so there's a lot of red, and then green and blue, there's slightly less, and then as it goes further on, my red goes down. That's these colors over here, but the green and blue stay on, and then when you start hitting the white space, it's all 255, 255, 255. So that's how it's going across, in case you're wondering. So let's just be a little bit consistent here. I only need head. think I can do that. No? Is that not a method? Gah. That's too much to look at. I'm just going to make a note here for posterity and future reference what I'm doing. Print, this was the byte or pixel value data from the NumPy array of the image I imported. Cool. So I have here just 3 images, and they're huge. They're like 14 megabytes for this one, 18 megabytes for this one, 24 megabytes for this one. When I open them up, I've got 9,000 by 600 pixels, 6,200 by 5,000. So they're huge files, and one of them, if not all 3 of them, have transparencies in the background. So I just wanted to double check, and you can see these dotted markers or whatever in GIMP denote that this part is all transparent. So if I throw anything behind it, it'll shine through. Where's my layers? Windows, layers. Gah. Why is everything so complicated? Okay, so if I put something on the layer behind it, you can see that it's definitely transparent. So what I want to do is programmatically convert these 3 images to lower quality first of all, so that they're not 14 megabytes each. I want to impose a background so that I can change them into JPEG if I wanted to convert the format. And this is really useful for anybody with just pictures they want to manage from like a pulled off your cell phone or something like that. Or if you're building websites, oftentimes you'll need thumbnails, like the small version, so that the picture loads really quickly, and then when the people click on it, then maybe they want to see the full quality version. But if you're just displaying a small version of the image, you don't need all that resolution. So to do that programmatically in Python is actually really easy. Well, I mean, I say it's easy, but I mean, it's easy in the sense that once you know it, or if you look it up or something, it's possible for anyone to do, but it's not easy. Off the top of my head, it actually took a couple hours to figure it out because I kept messing around with it. So I'll just give you the quick run through of how I did it. So first of all, I use the OS module to list everything in my directory, and then I'm going to do a check because I only want to take the files that are PNGs. So I'm going to first say if file dot ends with is PNG, only then do I want it to do this processing. And the reason is I don't want it to try and do this to the notebook that I'm working on. It would either error or come up with a recursive loop, so either way that's no good. So again, I'm going to use that pillow, this here, image that I imported from the pillow library, and once again I'm just going to open whatever file I'm in, because I'm iterating. The for loop is going to iterate through everything that's in the directory, and then for whatever's in that directory, whatever file ends with a PNG, it's going to open and says, what do you want to open? Well, the file that ends with PNG. So that much should be straightforward. And then I want to load that into memory because I'm going to start playing around with it. And the only way that you can create an image, because I need to need to create a new image that's blank with a blank background, because the background right now is transparent, but JPEGs, other image file formats, can't save alpha channels. So they need some type of background to know what to display, if not nothing, right? So I'm going to load this into memory, create a new image with a background color of whatever. I'm just going to make it white. And then I'm going to use, and then I'm going to paste what's been loaded here on top of that background. And then save the file as another file type in a different size or whatever after the fact. So to do that, I'm going to say like, file name and file extension. I'm going to set that equal to os path.split text. So from the OS module, I'm going to split the file name and the file extension so that I can save it again as the same file name but with a different extension afterwards. And I'm going to need width and height, so I'll just use W. I don't know why I always spell the whole thing out. Well, I guess documentation purposes. Okay, so width and height equals image.size, and size is going to return two numbers. So using a comma here, it's just going to assign one to the first, one to the second, just sort of shorthand. Then I'm going to say width equals, well, I gotta make an integer of it. So width equals width divided by 4. See, I've already stumbled into all the problems the first time I wrote this out, so it's a little bit quicker the second time around. It actually barks at you if you have decimal values, so it's confusing because sometimes it'll work as long as, like, if I divide it by 4 and it actually breaks evenly into 4, then there's no error, but as soon as you use a different image, then there's an error, so. Stuff like that can be hard to catch sometimes, so I'll save you the trouble of watching me fumble. So now I need that background, and I'm going to use that image object again from, I guess I don't need to keep going back up, but from the pillow, just in case it's getting confused with this IMG and stuff. And from that, I'm going to create a new image, and this takes very deliberate arguments. So this I had to look up in the documentation to get it right, but basically it needs that, it needs the size, and then it needs a tuple with three values in it, and I'm just doing white, and this is the background. I'm making a new image that's just RGB, so there's no alpha channel. I'm going to use the same size as the file that we're currently in, because remember we're looping through every PNG in the directory. And then I'm going to set the background to just straight white, but it has to be in a tuple and not an array, which is annoying, but another one of those mistakes that took me a while to catch. But now, since I've loaded the image into memory, I can paste it directly into this new image I just made. So that'll be image. Yeah, but I need the mask. The mask is going to be image.split. And I'm taking out the fourth index, which will be number 3, because it starts at 0. So RGB, my red, green, and blue, and then the alpha channel will be the 4th, so I'm splitting out that alpha channel from the original image so that it doesn't populate my color data with a channel that I don't want. And then I'm going to set the background to equal itself, but I want to resize it now that I've put the transparent PNG on top of my new RGB color space and pasted it in. I can now resize it using the pillow library's built-in method for resizing. And I'm just gonna set that to the width and height that I wrote down earlier. but that has to be a tuple. Another one of those like really specific things to the differences between Python and JavaScript are readily apparent in a script like this, whereas in JavaScript you don't have tuples, you don't have these kinds of demands on your inputs and your parameters. But yeah, just whining. So I have to make a new file name. So I'll call that new file name. And I'm going to use the file name that I put up from here, that I extracted from the path, from the OS module, from the file. Because remember, I'm just going through everything that's in the directory. The current directory is just the period, and everything with a PNG ending. So this fxed is always going to be PNG in this case, because everything in this if statement only processes if the extension's a PNG. And the file name I'm going to create is just the file name from the path, which is, image manipulation, and then img1 would be the beginning of the path. But I'm going to change the file name just by concatenating a .jpg to the end, because that's the file format I'm going to now save it to. So background.save, and I'm going to use new file name. That's this here. The other argument has got to be capital JPEG, and I'm going to just throw in a quality adjustment here, because I really don't need a full quality JPEG for an image that size. Remember, it was like 6,800 pixels or something, divided by 4, because I've resized it up here. So I'm changing the size of it before I save it, so it doesn't fill out the whole screen when you open it. And then I'm going to set the quality lower to see if we can get that file size down to like really, really small. Instead of like 1 megabyte, maybe it'll be like 100 kilobytes or something like that. I'm not sure exactly, but yeah, so if I run that, that should just work. Ooh, maybe not. File name, posx in path, no attribute split text. Why is there no attribute split text? Oh, not text. Ext. Split extension. Name width is not defined. Line 9. Wait. Yikes. Paste. Mask equals image dot split. Method object is not subscriptable. Split is the method. And then I'm only drawing out the fourth element from the split. Yeah. Let's try this again. Tuple index is out of range. Oh, that's because one of the images does not have an alpha channel, and that would be this smile image here. Yeah, that's why I'm getting that. So we can ignore that, actually, because that should be expected. And I don't really want to get into like unit testing and edge cases and stuff right now, but as you'll see, I've got JPEG images now. So I'll open the original image one. And remember, that one's got the opacity in the background. 6200 by 5000, and it's 14 megabytes. And the JPEG version... Is that the same one? Image 1, image 3. There we go. Image1.jpg is now 1550 by 1250, and it's only 73K. And if you look closely, all these jagged pixels, that's the reason why. It's because we changed that quality down to 50 out of 100. So you'll see image 1. If I zoom in on this one, I can just keep going and going and going, and it takes a lot to get the quality to distort, because that's why the file size is so big, because of the quality adjustment there. So that's one way of making little thumbnails and stuff and converting from one file type to another file type. But there's actually a quicker, easier way of doing thumbnails, and I might as well show you that too. Since we've already gone this far, I'll just give you a little bit of something extra. So let's just take that width and divide it by 4 again, and the height and divide it by 4 again for the thumbnails. And then thumb image is the same as before, image.open. I'm going to say file name, thumb image dot thumbnail. So this is another one of the handy pillow methods. Pillow being that image manipulator library that I'm using. I don't know why I keep repeating that. So thumbnail size is going to be the only argument that I need for this parameter here, and that's just obviously what I've thrown in ahead of it. I'm gonna need to rename it, so thump. So thumb new name is going to equal thumb, and then I'll just give it the original file name. And then same thing as we did before, so thumb image dot save thumb new name. And then just to show you the kind of useful stuff you can do inside of Jupyter notebooks and stuff too, I'm going to delete all these JPEGs just so you can see they get recreated. I might as well. Starts with, not begins with. Starts with. No such file or directory image 3. Oh, I need just file, that's why. Yeah. So file name is just a string from part of the path. When I split the extension off from the file, it gives me the extension and it gives me the file name. What I actually want to open is the file itself, and the file itself is being opened from OS lister. Yeah, because that's what's going to be iterating through everything. So let me just get rid of this again. Delete. Just save it in case I make something crash. And then Shift Enter to run the cell. More errors. So file name is again without the extension. What I actually wanted to do is new file name. I do believe. Let's try this again. Delete, save, run. More errors. Cannot write RGB as a JPEG. I'm not asking you to. RGB, open file. What I could just do is open background because I've saved it. Okay, so it's definitely an issue with that background. So instead of that, let's just use new file name, right? Because that'll open the actual path to the thing I just saved here. And then it'll be a JPEG, so I'll be in the right color space to make my thumbnail out of the JPEG instead of making the thumbnail out of the PNG. I bet that will work just fancy-fee. Yeah, there we go. So this is one of the handy things about the notebook is this line here, show. Gives you a little pop-up window of the thing you just created. It's built with ImageMagick, which is open source and all that, which is nice. I think you can even do transforms and filters in here. Yeah, cool. What else? Image editing, you can draw on it. Fuzz? Sure. Anyway, play around with it at your leisure. Don't need to keep showing you. Don't need that open. Oh, I guess I did need that open. So what we've done is we've created from image.png this 14 megabyte colossal image with transparencies. I've now created a JPEG image copy, but with much, much lower quality, very, very small file size, and I resized it, and we've created thumbnails. And the thumbnails are even obviously worse quality, but you'll see like from far back, it's it's essentially the same picture, but without, I scaled it down by 4 again, so it's really small, 387 by 312, and it's only 13 kilobytes compared to, I can never remember what order these pictures are in. It's image 2, image 1. So the JPEG version that I downscaled is 1550 by 1250. And the thumbnail is 387 by 312. But it went from 73 kilobytes to 13 kilobytes, so shrunk it even more. Anyway, not crazy terribly important. The whole point is image manipulation in Python is very, very, very different from that in JavaScript, but you can do essentially the same things from one side to the other. You can get the byte streams, you can throw them into arrays, you can get hex string values. That's not even hex. I don't know what code that is. It's the B64 encode. I guess it's 64-bit byte stream. So probably using the alphabet. Yeah, so 26 letters in the alphabet times 2 is, what, 52? Yeah. So 52, and then you've got 0 to 9. That's 62, and then I'm guessing that's why there's pluses in here to make up the other 2 bits. So there's probably like a plus and a dash or something. It takes it from 62 to 64, and that's your 64-bit encode, because you've got lowercase and uppercase alphabet, 52, 0 to 9, which makes 62, and then I guess 2 symbols for, I don't know what the other symbol is, but plus is definitely one of them. Anyway, I'm not going to pretend to understand how to read byte encoding just yet, but we're going to be doing this a lot. I'm going to take a lot of like NumPy arrays, basically build out color values by normalizing them to 16 by 16, 16-bit color. And then once you list them and show them, you can programmatically check the images and compare them across each other and look for correlations, clustering, patterns, that kind of thing. So probably a lot more long-winded than needed to be, but at least now that I've gone through it in depth, I can just refer back to this video whenever I'm just doing a quick demonstration, and I can choose whatever's easiest for me to just throw it in Python quickly if I'm already in Python, or throw it in JavaScript quickly if I'm already in JavaScript trying to prototype an idea or check to see if something works. So hope that was helpful. I haven't seen, there's tons of image editing videos on YouTube, but not many are showing how to do similar concepts with two different programming languages in the same video. So I don't know, maybe this will be useful to somebody for that. Signing out. Oh balls, I just realized I completely forgot to cover something here. The bit streams like I was doing in JavaScript. I completely forgot to do bit streams. I just did the string stream and then gave up right away. So byte arrays, that's the word I was looking for. So just quickly before I go, let's say I'm gonna reopen, I'm going to reopen the same smile file that I did before. And I'm going to call it image file 2 this time. And let's just say like file 2.read. Let's just say I want to see what's in these. Oh, I guess it won't let me. Shizzle. Codec can't decode byte position start. Okay, so RB, that's what I forgot. So I have to read it as byte data. Let's see if we can get a help on, what is it, byte array? Help on class byte array and module built-ins. So class byte array is iterable of ints, that makes a byte array. Construct a mutable byte array object from an iterable yielding a text string encoded using specialized encoding, a byte or a buffer object. So this would be an image buffer. Any object implementing a buffer API, again, image buffer. Actually, technically, it's probably this, because the RB is what defines it being the byte reading it as a byte array. So this is probably the API that's creating the byte array object. Dunder methods, double underscore, they're just the built-ins that define the class, and these are all the things that you can do onto the object itself, as well as clear, copy, count, append if you wanted to add stuff to it. Append is like the push method in JavaScript. It just adds something to the end of the array. Expand tables, extend. So append all the items from the iterator or sequence to the end of the byte array. Oh, I didn't know about that one. I'll have to check into that later. But there's other useful stuff like finding specific locations. Hex values, create a string of hexadecimal now from the byte. Let's use that one. So hex. I'm just going to comment this out for now. Yeah, let's see if I can do it here. I'm not sure this will work, but oh, bangarang. Okay, so instead of F, I'm going to call this hex. Oh no, I will call this F, but I'm going to call f.hex. Print hexadecimal values for the byte stream. And then I just wanted to print f. And that'll be the raw byte stream. There, so at least we got a little separator. So that's the raw byte stream. It's the hexadecimal values for the exact same byte stream. Remember, these are all taken from this smile image here, so this would be really, really long for larger pictures. What else can I do? I'm going to say byte array. I guess that's sort of the same thing though, isn't it? Let's see. I'm going to try it with byte array just to see if it's any different. Which is just image.read, image, it's just image file 2 as a read buffer. Anyway, yeah. So when I run that, I should have printed it. Yeah, so this looks exactly the same if I'm not mistaken. NX00. I'm just going to comment this one out for a minute so I can compare them side by side. Actually, since we're into programming and everything, I can just take B and F and compare them together. Print B equals F. True. So all I'm saying is the double equals is a comparison, whereas a single equals is an assignment. So anything on the left of the single equals is saying make this become this value. But when you use a double equals, you're asking a true-false question, is this the same as this? But if I say equals, equals, equal, oh, that's a JavaScript thing. So in JavaScript, you have the third equals is comparing types as well. So not just the output value, but if you had a function that returns the number 2, instead of comparing the number 2 with the output of the function, the number 2, using a triple equals would say, like, is this a function that also returns number 2? Like, is it the exact same function, like, word for word? But not important. We're doing Python.